Okay, permutation is a specific type of counting, right? Counting principle is the big title. Underneath the counting principle is a permutation, which is a very specific way to count the number of possibilities. So a permutation will tell you the number of ways to arrange R objects given a total of n objects. It's an arrangement, right? On the first page, I was just counting possibilities. Permutations, the key word here is arrange. Arranging, which means that the order is important. A permutation is arranging objects. When you arrange something, the order is important. Okay, so the box is for the formula. We're going to say NPR. So we are going to say this is n factorial, right? Exclamation mark is the notation for factorial, divided by n minus r factorial. You do not have to memorize this formula. It will be provided for you. Okay, so in this particular case, Cn, n is the first number, n is the bigger number. Okay, now when I write my formula, I like to say start at n, write R numbers. And I'll show you what that means. Because sometimes it can be kind of tricky to evaluate that statement, so we're going to look at how it simplifies. Sometimes it is actually faster to do this by hand than to type it in the calculator. So we're going to look at both. Evaluate 6P2. Okay, 6P2. That's 6 objects. Arrange 2 of them. I have a group of 6 items, and I would only like to arrange 2 of them. Okay, so let's follow our formula. So the top number is 6 factorial. And then on the bottom, it's 6 minus 2 factorial. Notice the grouping symbols. That means that you should subtract that. So this is 6 factorial over 4 factorial. Okay? And if you watched the factorial video, you know that that exclamation mark means start at 6 and multiply all the way down to 1. It's a shorthand notation for starting at the number and multiplying, decreasing by 1, all the way to 1. And then 4 means start at 4, decrease to 1. And then I quickly see that the back half of this formula cancels out. That's why it says start at 6, write 2 numbers. start at 6, write two numbers, 6, 5. That's it. That's what the whole formula simplifies to. Which is actually 30. Right, okay, so do you have to go through this every time? Not necessarily. 6p2 means start at 6, write two numbers of the factorial. 6, 5. It's a really quick way to remember how this simplifies. Okay, yes, there's a calculator. You have the P button. You have this button in your calculator. So we're going to write down where it is. Okay, so you're going to press the math button. So press math. Okay, arrow over to the PRB menu for probability, because counting has to do with probability. And look right there. There's your factorial button. There's the P. So it's number 2. NPR. Now, depending upon what version of the calculator you have, sometimes the notation is a little bit weird. So I'm going to type 6. Notice that it's not letting me replace the N. You just have to type it in front. 6P2. If you have a newer calculator, you actually get the little boxes and you can type those in. But most of us, it's going to look like this. 30. What kind of work do you need to show? You should probably write 6P2 on your paper so I can see what you're using to count. Or you write 6 times 5 so I can see what you're doing to count. 30. Okay, how many ways can you arrange the letters Y-O-B? So 3 letters, arrange 3. That means I'm arranging all of them. That would be 3P3. That's okay. All right. I'm going to work it out the formula way so you can see the progression. So that would be equal to 3 factorial over 0 factorial. 0 factorial is defined as 1. Because factorials are actually meant for counting. The 0 factorial is how many ways can you arrange 0 objects? One way. There's one way to have an empty dinner plate. Just one way with nothing there. And so that is defined as 1. It's not dividing by 0. It's dividing by 0 factorial. And so this is 3, 2, 1. This is 1. 0 factorial is defined as 1.
Well, why don't you do 3 factorial on the bottom? Because
it's 3 minus 3.
Oh, that's true.
That's why. Okay, so we get 6. 6. 3P3. Now, once you type this once, it's probably easier just to go back and highlight it. 3. 6. It's going to give you the right number. You could even try 0, math, factorial. Yes, your calculator will give you 1. So if you're not sure, you can test it. All right, try 8 and 9. And if you get it, try 10, and then we'll come back and look at them.
Because 30 times 4. Oh.
You're a wheel. And I assume know all of this.
I'm just guessing, honestly. I don't know arithmetic in middle school.
Exactly. What did I say?
How bad it was school? Yeah.
So, how many of you think that in order for an electrical system to work, you need to hook up 2 wires to either side of the battery?
Yeah.
I don't know anything about
So, in order for an electrical system to work, you have your circuit, you have the battery, you have 2 wires going. 1, 2, they're negative.
Positive and negative. Where's the word?
Is that how an electrical system has to work? Or yeah.
Permutations is a subset of the
I mean, I knew it.
shorthand way of defining it.
Yeah, because you can't do it any other way. I didn't show you that. Actually,
No, what I'm saying is, there's actually a way you can avoid running the wire from this to the negative side of the battery. And it's just by shut up, nobody asked.
That's all it is.
Yes, it's a little bit more efficient. When you can literally have a wire running to the frame of your robot.
what I know about
Oh, you have to take it.
So you can run the
8,
wire
9, 10?
to literally just a big.
Yeah, keep going. Keep going. Okay. Yes, 6p3. Okay, that's because you have gold, silver, bronze. You've had 6 runners. Now we're saying assume no tie so that one person crosses the finish line at a time. So this is 6 factorial over 3 factorial, which is 6, 5, 4, 3, 2, 1, 3, 2, 1. And the back half cancels out. And we end up with just this. Guys, this is a subset of the counting principle. There's 6 ways for the first runner to cross. He's done. There's only 5 people left in the race. 5 choices for second place. He crosses the finish line. Only 4 choices left for third place. Permutations are a subset of counting principles. It's just a very specific way to arrange the winners. So we get 6 times 5 times 4. 120. 120 ways for this to happen. I would like you to be able to write the different formats because you might have to select multiple things that could be used to evaluate or find the number of possibilities. Okay, 10 preschoolers. We need a line leader and a line caboose. 10 P2. Only arranging 2 of them. 10 factorial, 8 factorial. That's a lot to write. I'm going to skip. 10 times 9. That's what it comes out to. 10 times 9. You're only arranging 2 of them. 10 choices. They go up to the front. 9 choices left. Okay, let's look at number 10. 6 seniors, 5 juniors. There has to be a senior president and a senior vice president, a junior secretary, and a junior treasurer. There's
11P4.
not quite. There's 2 events. Are your juniors running for senior president?
No.
No. I have 2 events. Senior election, junior election. Okay. Yes. Let's do seniors. Right? How many ways can you elect your seniors? How many ways can you elect your juniors? 6P2. Because that's arranging or picking 2 people. Now notice the order matters because a president and a vice president, those are different people. Like it matters which name goes where. They're different. Okay, junior, secretary and treasurer are different, and so you are arranging them. 5P2. Okay, so I'm going to do this. 6 times 5, there's my senior event. 5 times 4, there's my junior event. I don't always write the whole factorial notation. I like to skip sometimes to how it simplifies. 600 choices.
Oh, these are multiple.
Yeah. Their separate events are multiplied.
Oh,
Did I say the word or? No. Senior president and junior secretary. And so we are multiplying these choices together. All right. Last part of permutations right here. Arranging n objects when some objects are repeated. So we have our formula, okay? We're going to start with n objects arranged, and that is NPN. I'm arranging all of them. N objects, arranging all of them. But within this group, are objects are repeated. Then I'm going to say R sub 1. R sub 2. Objects are repeated, etc. Because you could have any number of things that are repeated. And what's going to happen is you have to divide by R sub 1 factorial, R sub 2 factorial. Formulas are a little tricky to understand until you see it working. So we're going to do it with this word banana. Okay. Banana. I'm going to count my letters. 1, 2, 3, 4, 5. So I have 6 letters. 6P6. I'm going to arrange 6 letters. Okay? And I look at my word. Let's look at the ends. If you swap the ends, is that the same word? Yeah. Okay. How many ways can you arrange 2 ends? 2 factorial. So in every arrangement of banana, I can swap the ends and it's the same word. And so we have to divide by 2 factorial. Repeat 2 ends. And then I look at that. Banana, 3 A's. 3 A's. If I rearrange all of the A's, it's still the same word. How many ways can you arrange 3 A's? 3 factorial. So repeat 3 A's. That's exactly what the formula is doing. Whatever is repeated, we have to divide out the rearrangements because it is still the same order. Okay, so here is the formula. So we end up with 6 factorial, right? 6p6. Start at 6, write 6 numbers. 2 factorial, 3 factorial, 6, 5, 4, 3, 2, 1. 2 times 1, 3 times 2 times 1. Oh, so 20, 60? 60? I'll check. Awesome. Oh, Here, I might as well do this. Okay? 60. Okay, do number 12.
Wait, why is it only 6 factorial?
6 objects. 66 is arrange the objects and then divide out the repeats.
Is that already like 66 and 8?
Yeah. Which is the same thing as 8p8. Start at 8, write 8, no. Okay, try the last one. Yeah, so R3, etc. R4.
It's literally just saying it's just more complicated.
No, 8 total. Because there are
Yeah.
8 bottles and you want to order all of them. Yeah.
Oh, is that
What?
everything's on there?
So, yeah.
Smash Ultimate's on it.
Everything's legal in Jersey.
Because if I rearrange the end, it still says banana, just two arrangements.
Wait, that's so you just
So
go
we
up the
have
elevator
EP
and
and
then so you go up the elevator and then you get
different.
Yeah, the warm stone.
so yeah.
I know more Mario secrets than you.
Yes.
I haven't done a speedrun. I've actually never beaten the game. I've gotten so close though. Oh! I never beat Bowser.
I will remove at least one of the batteries from your calculator.
They are quadruple red.
I know.
Do you have quadruple A batteries?
Yeah. This
Yeah.
one.
Are they just 8 factorial?
Quadruple A battery, right?
So 8 factorial.
What?
On our test, are we gonna have to
So
write the
I would.
actual number? Are we gonna have to plug it in?
I'll
and write-
probably ask for both the setup and the number. Just in case you type it in wrong, I can see what,
So
why.
it's like 2 changes.
So 6p2, 5p2, 600, right? Just so I can see whether you're choosing P or C, which is what we're going to do next.